Hello and welcome to Module 5 of Part 1 of the Cōnsilium Aquīs course on ETCS. This module covers ETCS onboard equipment, vital processing and logging equipment, interfaces to drivers, trains and trackside equipment, and odometry equipment. At the heart of the onboard unit is a safety critical computer, the European Vital Computer, EVC. This continuously monitors information received from the ETCS trackside and collates it with train odometry information. It calculates safe speed profiles for the train and intervenes if the train travels too far or too fast, providing automatic train protection. It generates cab signalling and status information to present to the driver. Some implementations can also drive the train, supporting automatic train operation. The Juridical Recorder Unit, JRU, logs messages to and from the train and states within the ETCS onboard unit. These are stored in tamper-proof memory, accessible through a standard interface. The purpose of the JRU is to provide a record of events, informing investigations should an incident occur, like an aeroplane black box. Onboard units interface to drivers via driver-machine interfaces, DMI. DMIs are located in drivers' cabs and present information to drivers via VDU screens. Depending on its architecture, an onboard unit may have one or two DMIs. Depending on the DMI, drivers either interact with a touchscreen or soft keys around the screen. The driver also has an isolation switch, by which onboard unit interfaces to the train can be disconnected in the event of failure. ETCS onboards may have hardwired interfaces to the train, or interface via computer networks, or by a combination of the two. ETCS onboard units interface to trains to apply emergency brakes, instigate traction cutoff, receive cab activation status, and receive direction controller positions. ETCS onboard units may also apply service brakes, switch off special brakes, switch off main power switch, lower pantographs, switch between electric traction systems, change allowed current consumption, and apply air tightness. Inputs from the train may also be used to trigger onboard units entering specific ETCS modes. As a minimum, to support ETCS Level 1 operation, an ETCS-fitted train has a Belize antenna to power and read Eurobelises that the train passes over. This typically interfaces to the EVC via a Belize transmission module, BTM, that generates power for the Eurobelises and decodes the telegrams received. Where Euronoops are used, an additional antenna and loop transmission module, LTM, may be provided to read them. For ETCS Level 2 applications and for ETCS Level 1 radio infill, a data radio antenna and modem is also required. Odometry equipment is used to determine train speed and position. Train position is expressed as distance travelled since the last relevant balise group, LRBG, read, and has an associated confidence interval. Odometry information is generally taken from diverse, duplicated sources to achieve high safety integrity and availability. Typically, this will include tachometers and Doppler radars. A tachometer counts the number of revolutions of a train axle. Multiplying this by wheel diameter yields distance travelled. Correct calibration of wheel diameter, particularly after wheel turning, is essential for safe tachometer distance measurements. Ideally, tachometers should be mounted on non-braked, non-powered axles to avoid distortion due to wheel slip and slide. Doppler radars measure speed by measuring the Doppler shift in microwaves transmitted and reflected back from track beneath the train. In summary, at the heart of each ETCS onboard unit is a vital computer that performs automatic train protection, cab signalling and, in some applications, automatic train operation functionality. A juridical recorder unit logs events and messages for analysis in the event of an incident. Drivers interact with onboard units via driver-machine interfaces in their driving cabs. Drivers can also isolate onboard units via an isolation switch. As a minimum, onboard units can instigate brake application and traction cutoff and receive cab and direction controller status information. Antennae power and read Euro-balises and may also read Euro-loops. Trains capable of ETCS Level 2 or Level 1 radio infill also have radio antennae and modems. Odometry equipment measures distance travelled since the last balise group with a confidence interval and speed.